All right. Well, we are back again, another late night stream. I am consistently starting up the stream pretty late. But today I want to do something a little bit different. Uh, I'm not sure whether I want to like switch it up this much quite yet, but I think today we're probably going to be doing, um, we're going to obviously finish our reviews here. Uh, but we're going to go into the chemistry section a little bit. So obviously these two chapters are pretty short. So I might combine them and just do both. Uh, do them both today. Um, that way we're not just like drilling one subject. I tend to end up drilling bio and biochemistry, but I don't know. I want to leave these. I didn't watch the Yusuf Hassan videos today. So once I start watching those is when I want to get back into doing bio and biochemistry. Until then, Pancal's probably fine. For like Pancal chemistry, I don't know about orgo and physics. Orgo and physics, I might need to. I might need to watch videos for those too. Um, but all right, we can get started. I'm not gonna forget the lo-fi today. I know I forgot yesterday. Well, not the whole time, obviously, but all right. Let's go biochemistry. I don't know why it says we have one review. What is a conjugated protein? So I actually want to lower the lo-fi a little bit. It's a little loud. What is a conjugated protein? Um, a conjugated protein is a protein that derives a part of its function from its prosthetic group. Okay, I think I would say that's right. With the exception of glycine, they're all chiral. What is denaturation? Like the when a tertiary peptide or protein is brought into like its primary structure, like it loses its shape. I was trying to be so technical with it, and I genuinely didn't even need to do that. What is a peptide? It is a chain of amino acids. Nice. What is a globular? It's a protein that's round and spherical in shape. Cystine is what you refer to the bond, or like how you refer to the disulfide bond within a protein or in a protein. What is arginine structure? I feel like for these in particular, it generally might be easier for the it might be easier with a different background, with the other background that I was using before. I think that honestly, it just works better as a blank canvas. What is arginine structure? We're gonna have boom, boom, okay. Obviously, there's an OH here, and then arginine is one. I think it's like an M, and then we have an N here, which obviously that's an NH2, not a methyl. Okay, cool. I didn't. I like know this. I remember that. That's fine. Okay. So phenylalanine, PHE F. It's aromatic but nonpolar. Or and nonpolar. Uh, boom boom, and then it's gonna be like the ring. Yeah. Glycine. All right. We all know it doesn't even have an R group for me to draw besides H. Um, Character, nonpolar, GLY, and G. What is secondary structure and what is its characteristic bond? It's hydrogen bonds between the amino and carboxyl group. I don't think there are any other ones, right? Yeah. Okay, cool. Um, Peptide bond formation, it's a dehydration. If the pH is higher than the pKa of a group, then the group will be, if the pH is higher than the pKa, it's going to be deprotonated. Loki, they should have asked questions where they flipped it. Like if the pKa is higher than the pH, that would be trippy. Um, what are alanine structure, character, three-letter abbreviation, and one letter? Ala A is the 3 and 1. It's alanine is literally just a line like that. It's non-polar. What is a fibrous protein? It's like strands, or what was the word they use? I feel like it's just like sheets or strands. It's like weird. This is like this is literally a rod. I don't care. What is cysteine structure? Boom boom sh. Cy. It's probably. I'm pretty sure it's cys, and then C. Which amino acids are most commonly targeted? Serine, threonine, and tyrosine. How does one calculate isoelectric point? It's the average between like either your your carboxylic acid and amino, uh, like the pKa of each one of those. Um, so the average between the pKa of those two in a neutral, between the carboxylic acid and the R group in an acidic, and between the amino and the R group in a basic. I think I have that down, to be honest. From N to C terminus, left to right. I know sometimes I finish the answer after clicking show answer, but I promise I'm not looking. I'm if I click it, I'm looking down at like the bottom of the computer. Glutamic acid, boom boom, and that's the carboxylic acid. Oh wait, hold up. I should have. So it's glue, then E, then the nature obviously is acidic, so it's negatively charged. That's it. Alright, cool. What is a polypeptide? It consists of, it's a peptide chain of more than 20 amino acid residues. Oh my god. I'm gonna look up the difference between a polypeptide. What is versus. I just want to know what, like, all, I feel like they refer to it in so many different ways, and it's starting to get annoying. It's like, what is a peptide chain, and are all peptides peptide chains? Why sometimes they say peptides, sometimes they say peptide chains, like,
Discovery, go and throttle up. Discovery 4 computers now have
okay.
primary
I feel
control
like
of
it's
critical
fine,
vehicle
bro.
functions.
What will the titration curve? It's gonna look like a combination of monoprotic amino acids. Wait, no, monoprotic titration curves. It's like two or more. All right. There's a prosthetic group. Uh, prosthetic group is. I love this add-on so much. Um, what is a prosthetic group? What are some examples? Um, a prosthetic group is a group that is covalently attached to a protein that allows the protein to perform its function. Examples are like organic molecules like vitamins or metals like iron. What are tyrosine structure? Boom, boom, ring, boom. That's OH. TYR and Y. C terminus is the carboxylic acid end of a chain of peptides. So the peptide bond's in the middle though. Valine is going to be boom, boom, boom. What is quaternary structure? It's a it's it's like a combination of multiple tertiary structures that combine to form one overall quaternary peptide. Hold on. I need to copy this. I just really is this okay. I kind of want to give myself in again on this because it's like overall structure obtained when two or more separate polypeptides in tertiary structure combine. Okay, so again, describe the strength of the peptide bond and why. Because of resonance stabilization. What is the? I just don't feel comfortable clicking like good. What is DNA sequencing? How is it done? So they're going to separate the sample into four separate tubes, then run it through PCR or gene cloning, in which you have ddNTPs, which prevent elongation from the 3' end. When these bind, because they're binding randomly into different locations, it ends up being the case. One second. because they're all binding in one place, um, or they're all binding in random places, it creates strands of different lengths. And in each one of the separate tubes, you're gonna have different DDNCPs with the four different nucleotides, which is going to cause obviously the different lengths, and that when run through a gel electrophoresis is going to basically create one step up every single time. Like it's gonna be like one nucleotide longer every time, so you're gonna immediately be able to see that okay, this one was longer, so that's the next nucleotide. This one, so on and so forth. I think I have a pretty good understanding of that. Okay, this one is it's gonna be like boom, 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 boom. What is a beta pleated sheet? Beta pleated sheet is when um, multiple protein chains lie next to one another, forming rows. Okay, I'm trying to figure out what the difference between protein and peptide is again, because I genuinely don't know. The protein is a longer chain of amino acids, generally 50 plus. Peptide is shorter, from 2 to 50.
Every four computers now have primary control of critical vehicle functions.
Okay, I guess it probably will never refer to it as a protein. Then, if it's peptides are just 2 to 50, and then proteins often have like a lot more. Okay, I did save this though. That was my answer. What are t- what are two main what are two main structural classes of proteins? Is globular and fibrous. What is a glycoprotein? A protein with a carbohydrate-based prosthetic group. What is methionine structure? Boom, 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 boom. S. It was also met, nonpolar, and M. What are asparagine structure? Asparagine was boom, 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 and then the double bond to oxygen and the NH2 there. It was polar. Oh, I didn't do these. I probably would have gotten it, to be honest with you. Leucine, boom, boom. Leucine. I think leucine is just a longer valine.
That's one small step for man,
Okay.
one giant leap for
Zwitter ion, it has an overall negative charge, an overall neutral charge with overall neutral charge, and it has both positive and negative show up on it. Glutamine, boom, 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 boom. Then this is the Dovan to O, NH2. This is Q, weirdly enough, Q, and or Q, glue, not glue, GLN, and then it is polar. What is the isoelectric point? Isoelectric point is the point at which the molecule is neutral, like overall. What is a salvation layer? It is the layer that forms around a molecule by nearby solid molecules. What is lysine structure? Boom, 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 boom. And then this is going to be the NH, whatever. is the only one in our configuration. Um, uh, okay, I'm gonna try to get a background that this can actually be seen in. Okay, I feel like this one should work. Um, I feel like this picture should probably be good. It's like I never put in a background that's like white. Everything else just like flashes. Alright, that's at least a little better. All chiral amino acids are they're L and cysteine. Proteinogenic are about 20 amino acids encoded by the human genetic code. Proline is gonna be boom, 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 boom. Okay, pretty sure that's it. It's pro, P, and it's not polar. Histidine. Okay, boom, boom. Right. So it's gonna be boom, boom, boom. Nice. Histidine. Histidine. Yeah, that's basic. That's basic. H. Okay. Protein with a nucleotide-based prosthetic group. What is a residue in an individual amino acid on peptide? You see, I almost said protein. Describe the special role played by proline in secondary structures. It causes, because of its like rigid structure, it causes kinks. It causes kinks and like kind of messes with the stability of the second of like alpha helices and beta sheets. So you find them mostly at the beginning of alpha helices and in the what's it called? In the turns of beta sheets. structure and what is its characteristic on? Um, it's the sequence of amino acids. It's peptide bonds. Tryptophan, TRP, and W. Then we're gonna have. Okay, this one is kind of rough. I remember that. Okay, so then
New
I
year,
feel
new
like
me? Cute. But how about new year, new money? With
I think it's
Experian, you can
here.
actually take
And
control of your finances.
no, it
Check your
can't be
FICO
there.
score, find ways to save, and get matched with
They
credit
can't
card
be there.
offers, giving you time to power through those New Year's goals
I think
you
it's
know
here.
you're going to crush. Start the year off right. Download the Experian app. Based on FICO Score 8 model, offers and approval not guaranteed. Eligibility requirements and terms
It's
apply.
here.
Subject to credit check, which may impact your credit scores. Offers not available in all states. See Experian.com for details. Experian.
I think it's there and there. And that makes sense. It's polar as well. It gotta be. No, it's not. Tryptophan cannot be polar, right? It's not. It's not polar. Okay. For the first time, I actually put it in a really bad spot. Uh, okay. Well, I got it right. So, aspartic acid, boom, 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 and then carboxylic acid, ASP and A. Wait, not A. SP and D. It's acidic, negatively charged. That was close. What roles can the formation of quaternary structure serve? It can stabilize a protein, reduce the amount of DNA necessary to form a protein complex. Uh, it can help bring catalytic sites together by shuttling intermediates from one step to the next and help induce cooperativity. What are serine structure? Serine is just like, I think it's, is it like that? I feel like it, I think, I think that, yeah, this is serine. This is OH. This is just OH. I was just trying to make sure I didn't get that wrong. What is an oligopeptide? Um, Oligopeptide is a peptide with less than 20 amino acids attached. Yeah, okay, cool. What is quaternary structure? Quaternary structure is the combination of I think I'm just gonna say hydrogen bonds between side chains, as well as solutes like DTT and beta mercaptoethanol to disrupt disulfide bonds, and detergents to disrupt non-covalent bonds. Salt bridges. Oh my god. Yo. What is a subunit? Um, it's one of the functional tertiary structure um, peptides within a quaternary structure. What is a tertiary structure? What is its characteristic bond? Has hydrogen bonds. Hydrogen bonds between its. It's the 3D shape, but hydrogen bonds between its side chains, disulfide bonds between cysteine residues, and salt bridges between its positively charged and negatively charged residues. Or R groups is what I mean. What are threonine's structure? Okay, so it basically just goes boom, 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 and then this is OH. I knew that was correct. Ionizable groups tend to be LOPH. Ionizable groups tend to be deprotonated. No, protonated. What are common methods to denature proteins, and what do they do? So you're gonna have protein. So you're gonna have heat is going to destabilize hydrogen bonds, and salt bridges, solutes like DTT and beta mercaptoethanol are going to disrupt disulfide bonds, and detergents are going to disrupt non-covalent interaction. Right, now we can go into Mr. Pankow. Alright, let's see. I'm gonna edit this actually. I don't wanna accidentally steep into the we're gonna put 0 new cards for now. I'll edit it back after. I just want to make sure that I don't accidentally go into new cards for Mr. Pankow. Alright, cool. Oh, great. Here we go. Stick drift. My favorite. Alright. Just noticeable difference is the threshold at which you're able to notice the difference. Oh, damn. I low-key should have said sensation. Hearing adaptation involves constricting the inner ear muscle to dampen vibration and protect the tympanic membrane. Damn, they low-key. They know I know this. The otolithic organs contain hair cells which attach to contain calcium carbonate crystals which attach to hair cells to trigger action potentials to determine which way they're up or down. I didn't really look at the okay. Otoliths are ear stones. Those have a name. The sensors hairs, they have a name. I just forget. I know it starts with a K. They include the utricle and the saccule. Shading and contour, filled with endolymph. Slow adapting neurons fire at the beginning of the stimulus and calm down after a while. Autolytic organs fires at the beginning, then stops, then starts firing again at the end. Under conditions of uncertainty, the sense of the body's position in space. Things that are farther away move slower, and things closer move faster. Visual cues contribute to the phenomena of dizziness and vertigo. The vestibular system, blank neurons fire at a constant rate. Non-adapting neurons. Somatosensation of position is called proprioception. Fires as soon, fast-adapting neuron. Nociception, mechanoception, thermoception. Our perception of an object doesn't change constancy. The sense of a position of the body, proprioception again. Give a sense of depth through motion. This is motion parallax. It's a monocular cue where an object is perceived as being further away when it is higher in the visual field, relative height. Visual cues, monocular cues, depth, and downregulation of sight when it is bright outside. Our pupils constrict and they become desensitized to light. Is a monocular cue where which are relative size provides a sense of balance and spatial orientation. Okay. Semicircular canals. Autonomic organs help detect. Why do I have one due card? Did I get something wrong? I don't even remember. I literally just did. Autonomic organs help detect. They help detect head positioning and linear acceleration. Looks at how humans make decisions. The signal detection theory. I love when I read that. It used to discern between important and unimportant signal. Oh, sorry. Damn. Why'd I keep doing that? I didn't do any of that. Okay. Looks at how humans make decisions under. I think I might have done that for that one due card. I think I must have picked again by accident. Looks at how humans make decisions. Okay, I did this already. Absolute threshold of sensation is the that is the minimum intensity for a stimulus that is necessary to detect a particular stimulus 50% of the time. Yeah, that probably looked like I was reading from it. Is minimum intensity of stimulus, the absolute threshold of sensation. I don't know, noise, just noticeable difference. States that the just noticeable difference divided by the initial intensity is constant. Fire at the beginning, slow adapting. It can be influenced by expectation, experience, motivation, and awareness. Same thing. Is the stimuli subliminal stimuli? Visual cues include depth, form, motion, and constancy. Allow us to perceptually organize. Hearing adaptation. Our senses are adaptable and they can change their sensitivity over time. Our senses are adaptable and they can change. Sensory adaptation. They dilate, begin to synthesize light-sensitive molecules. Being closer when they're in front of something is a condition. Binocular cues include size, interposition, relative height, motion parallax, shading and contour, and I think it's constancy. That are a result of binocular cues, convergence. You're able to notice. Oh yeah, notice a change in sensation. Okay, so now we can change this back. We're gonna do history, so we can change this back to like I'll put it to like 60. I'll actually put it to 70. Okay, okay, yeah, I feel like this probably shouldn't take long. This is like basic stuff. What does the principal quantum number represent? Like it's not. I wouldn't say it's like it's gonna be like super duper easy or anything, but it's definitely like it should be on the easier side. It represents the shell, right? Something like that. The shell of the electron or electrons energy level. Um, I don't know if that's right, so I'm gonna say no. I'm gonna say I was wrong. What are the possible values for n? Like integers? Yeah, I mean, I got it wrong, but I'm not gonna forget that. What is the Pauli exclusion principle? I think Pauli might be greedy. So I think Pauli is, or maybe some other dude is
The
greedy. I
YouTube
guess
Music app has
I
the
don't really
power
remember.
to sense what you
Pauli
like from the moment
is
you open
going
the app.
to.
It's almost like it can read your mind.
Let's
That's
see.
what I
Let's
was
see what
going
it
to
was.
say. Get
No two
YouTube Music
electrons have
Premium.
the
Try
same
1 month free.
four quantum numbers. Okay. What is the fourth quantum number? Is that magnetic spin? I got that right. How long does an atom stay in the excited state? What does the principal quantum number represent? It represents the energy level. What are the possible values for L in terms of N? L, I think, is probably equal to 2N. Oh, damn. Okay, I don't know what I'm thinking. I'm probably thinking of the next one. There's N, L, and then there's one more, the third. The third one is the one that I don't remember. What are the... I don't even remember what L is. L might be subshell. Integers ranging from 0 to n minus 1. What are possible values for n? Any positive integer besides 0. Yes, to infinity is kind of implied there. What is the Pauli exclusion principle? It means that no two electrons can share the same quantum numbers, the same four quantum numbers. How long? Not long at all. What are the possible values? It's 1/2 and -1/2. What is a valence electron? A valence electron is an electron on the furthest shell. I think I'm gonna say that's pretty much what I said. What does it mean for energy to be quantized? Energy only comes in discrete packets. If one number value, you can either have 2 or 3. Okay. What are the possible values for L in terms of n? So it can range from zero, I guess. So n minus one. Okay, cool. What are the s, p, d, and f azimuthal quantum numbers? Those are L.
Watch all FIFA World
Oh,
Cup matches on Fox
okay.
One
I
with
didn't. I didn't
YouTube.
know.
Add over
Okay.
45 streaming
All right. You
services
see,
in one
I
app.
didn't. I didn't know what it was asking me. I probably could have gotten this pretty easily. What are the values, the possible values of ms? It's negative one half for downspin and positive one half for upspin. What are the special d orbital modifications we must make to the electron filling order? Um, well, the D, the d orbital fills in is, I think it's a higher energy level than like 4s. So it's gonna go after the next one's s. Oh, I didn't know. Okay. Okay. All right. I wasn't thinking of that. What does it mean for energy to be quantized? Energy comes in discrete packets of whole numbers. So it can be 2 or 3, but not 2.5. Um, what are S, P, D, and F? It's just 0, 1, 2, 3. What is the atomic number of an element equal to the number of protons? What is it? It's protons plus neutrons. I'm gonna easy that one. I'm gonna easy those because I didn't do it for the first one, but the second one I definitely did that. What is the second quantum number? It's L. I think it's literally called like the azimuthal quantum number. Angular momentum. Okay. What does it mean for an atom to be in an excited state? What are the special d orbital modifications that we must make? I didn't say anything, but I just clicked again because sometimes I don't know it. Like I don't know what they want me to say. What are the special d orbital modifications we must make to the electron filling order? So since the d orbital is it's more stable when it's half full or completely full. If it's one away, like if it's below and one away, then the s orbital will give up the the outermost s orbital will give up one of its own electrons to make it either full
Yo, this is
or
John
half full.
Bellion. Tune into my full live concert from Forest Hills on YouTube, your one-stop shop for music.
Okay. What is the third quantum number? I don't know. Magnetic quantum number. Okay. What is the second quantum number? The azimuthal quantum number or the angular momentum? What is the fourth quantum number? The magnetic spin? I'm not going to say quantum number every time. What does it mean for an atom to be in an excited state? It means that one of its electrons is in a higher shell than normal. What is atomic weight? Um, okay, I have a feeling that this is asking me something. This is asking me something different. So let's see. Weighted average of all stable isotopes of the atom. Okay, I understand. What does the principal quantum number represent? Um, what does the principal quantum number represent? Represents the energy level. What is the third quantum number? Third quantum number is the was it the magnetic quantum number? I'm gonna give myself again because I didn't remember. It was like M sub L. What is the Pauli exclusion principle? No two. It says that no two electrons can have the same four quantum numbers. What are the possible values for n? It's any positive integer besides 0. From integers ranging from 0 to n minus 1. I thought this doesn't sound right, low-key. What is a valence electron? It's one of the electrons in the furthest shell. It's the weighted average of all of the isotopes. Which is the third? It's the magnetic quantum number, or M sub L. How do you calculate the atomic weight of an atom with two naturally occurring isotopes? Well, you have the mass number of one of the isotopes and multiply it by its percentage, its like prevalence, I guess, and add it to the prevalence multiplied by the mass number of the other isotope and divide that by 2. Oh, I don't know why I divided by 2. That makes no sense. I forgot. Like, if you're doing the percentages, it doesn't even make sense to divide by 2. You're already splitting it. What are the possible values of m sub s? Negative 1/2 for downspin and positive 1/2 for upspin. What does magnetic quantum number tell you? I don't know. Which orbital in the given subshell? Okay. What does it mean for energy to be quantized? It means that energy comes in the form of discrete packets of energy that can only be whole integers. Yes, obviously positive. I know it can't be negative. It doesn't say positive, but what are the SPDF 0123? Okay, how do you calculate the atomic weight? It's percent frequency multiplied by mass number plus percent frequency multiplied by mass number of the other isotope. That formula isn't even it's not even detailed. How much mass does an electron add? Like, not much at all. 1/2000th of a proton. I don't see why I need to know that, but how do you determine the number of valence electrons an atom has? Just add everything in the last shell, and that's how many valence electrons. subshell is going to basically give one of its electrons if it's like one short of half full or completely full. So yeah, not long at all. Which is the fourth quantum number? M sub s. It's magnetic spin. How much mass? 1/2000th of an electron. Okay, all right. I said electron. Which is the second quantum number? L. The azimuthal or this is not the angular momentum. Okay. That was kind of hard. What does it mean for an atom to be in the excited state? It's in a higher shell than it normally is in. How do you determine? Look at the column. What is the atomic number of an element equal to? The number of protons. What is the Heisenberg uncertainty principle? It says that you can't know the position and velocity of an electron at the same time. Position and momentum. How much mass does an electron add to an atom? How much mass does an electron add? 1/2000th of a proton. What is Hund's rule? What is it? All orbitals in sublevel have to come first in must first have one electron before any orbital can obtain a second electron. It was Hund. Hund doesn't like greedy people. Hund is going to keep you from gathering hundreds. Hund is a communist. True story. Nothing wrong with communism or anything, you know what I'm saying? All orbitals in sublevel must first have one electron before any orbital can obtain a second electron. We can say again. What is the Heisenberg? You cannot know the momentum and position of an electron simultaneously. What does it mean for an atom to be in ground state? It means it's in its normal energy level. I didn't read that question properly. What is the speed of light in the air equal to? 3 times 10 to the 8th meter per second. What is a photon? It's like a particle of light. Massless, wave-like, and particle-like packet of electromagnetic energy. Massless, wave-like, and particle-like packet of electromagnetic energy. Massless, wave-like, and particle-like. What is Hund's rule? Hund don't keep you from getting hundreds, so he distributes the electrons evenly between the orbitals of each subshell, in order, obviously. different background even. 'Cause why is this? I don't like how this particular one sounds. Let's see if this one. Let's see if this one is cool.
Not the abs. Supergirl.
Moving. Spec.
Let's try this one. All right, cool. What is atomic weight? Atomic weight is the weighted average of all of the isotopes of an atom. What is the third quantum number? This is just the magnetic quantum number. What is the valence electron? It's an electron in the outermost shell. Any positive integer that's not zero. What is the Pauli exclusion principle? Pauli exclusion principle says that no two electrons can have the same four quantum numbers. What does the principal quantum number represent? It represents principal quantum number represents the energy level. What is a photon? It's a massless, wave-like, particle-like packet of electromagnetic energy. Bar for bar. What does the magnetic quantum number tell you? Okay. This song has a lot of action going on. And it's vibey, but I just need to turn it down. Okay. What does the magnetic quantum number tell you? It tells you the orientation, like which orbital in the subshell. What are the possible values for L in terms of n? It ranges from 0 to n minus 1. What are the possible values for ms? Negative 1/2 for downspin, positive 1/2 for upspin. What is the second quantum number? The second quantum number is the azimuthal or angular momentum quantum number. How much mass? 1/2000th of a proton. 0, 1, 2, 3. What does it mean for energy to be quantized? They come in discrete packets, like that can be expressed in whole numbers that are positive, whole number values only. How do you calculate the atomic weight? It's percent frequency times the mass number. Or I meant times. I don't know if I said times. What is an atomic emission spectrum? Catalog of photons of light emitted by a set of atoms. between energy levels are different in every atom. Photon release can determine atomic identity.
That feeling when you check your bank account and your paycheck's days away. And of course, your calendar's all
There we go.
good news. With Chase Secure Banking, your direct deposit hits your bank account up to 2 days faster. So when your friends are like, and your bills go, you have the peace your deposit brings. And the best part, there's no monthly service fee for 17 to 24-year-olds. Thanks to Chase Secure Banking.
For Chase Secure Checking only, eligible direct deposits may be credited up to 2 business days early, depending on when the payer submits the transaction. Member FDIC.
What is special? They like to be half full or completely full, so the S can donate an electron. What does it mean for it to be in the ground state? It means that all of its electrons are in the lowest possible energy shell that they can occupy. What is the fourth quantum number of magnetic spin? Magnetic spin. How do you determine the number of valence electrons that can come out? What does it mean for an atom to be in an excited state? It means that I think one of its electrons is in a higher energy shell than its energy. What number follows the element name when naming an isotope? Its mass number. How does one relate a photon's wavelength to its frequency? It's their inverses. My fault. They haven't. I don't know. C is equal to wavelength times frequency. What is an atomic? It's a catalog of photons emitted by the atom or by the electrons of an atom in their excited state. Or falling while in their excited state. Photons of light emitted by excited atoms. The valence electrons determine when atom reacts principal energy level goes up, the electrons raise to increase in velocity. What is a photon? It is a massless particle and wavelength. It's a massless, wave-like, and particle-like packet of electromagnetic energy. What is the Heisenberg uncertainty principle? It says you can't determine the momentum and position of an electron simultaneously. How do you determine C is equal to wavelength times frequency? What is an atomic? It's a catalog of photons emitted by an excited atom. Generally speaking, the valence electrons determine the determine the way that an atom reacts and its chemical properties? What is Hund's rule? Everyone gets one. You get one. Every orbital in the subshell gets one electron before anyone can grab another one. What does the azimuthal quantum number represent? It represents the subshell. That's what I meant, like the shape. Subshell shape. What are the possible values of magnetic quantum number? It's I don't know. Negative L to L. What is an isotope? It is an atom that has a different mass number compared with they're atoms with different numbers of neutrons, but the same number of protons. I know what it is. What does the azimuthal quantum number represent? It represents the subshell shape. How does one calculate the energy required to remove an electron from one energy level to another? All right. This is kind of crazy. How come they gave everything except for the Rydberg constant? Do we not need to know it? Do I need to know the Rydberg constant? Is the Rydberg constant important for MCAT? Okay. Okay, so I basically need to remember both these equations, it seems. Well, let's get the Rydberg constant because they decided not to give it to me. 2 point, it's gonna be 2.179 times 10 to the negative 18th joules per electron. Okay. Okay, so all right. What are the possible values of magnetic quantum number? What are the possible values of magnetic quantum number? What's it called? Negative delta. What does the magnetic quantum number tell you? I don't know. I don't know why it's. I feel like that's a strange thing, but whatever. So have like, let's say it's like negative 5 to 5, or that doesn't even add up. Whatever. I got that one. What is the second quantum number? Asymptotic quantum number or angular momentum? How much mass does an electron add to an atom? 1/2000th of a proton. How does one calculate the energy required to promote an electron from one energy level to another? How does one calculate the energy required to promote an electron from the energy required to promote an electron from one energy level to another? Oh, this is going to be the E is equal to Hc divided by the wavelength, I think. And that's going to be equal, H is going to be 6.6 times 10 to the negative 34th joule seconds. The Rydberg constant is 2.18 times 10 to the negative 18th joules per electron. And it's going to be negative Rydberg constant times, in parentheses, 1 over N, I'm going to say NF minus 1 over Ni, close parentheses, and both the ends are squared. Damn, Ni minus NF, bruh. Okay. I guess Ni in the denominator, since it obviously is going to be less, it'll be the bigger number. Okay. Alright, What does it mean for it to be in the ground state? It means that all its electrons are in the lowest energy shell that they can occupy. What does the magnetic quantum number tell you? It tells you the orientation of like the orientation of the subshell. Okay, all right. I'm gonna give myself an again for that. What number follows the element name when it means it's the mass number? Generally speaking, the valence electrons determine the way the atom reacts and its chemical properties. How does one relate a photon's wavelength to its frequency? Well, C is equal to wavelength times frequency. So, what is a photon? It is a massless, wave-like, and particle-like packet of electromagnetic energy. What is an atomic spectrum? It is a catalog of photons emitted by an excited atom. How does one calculate the energy required? So it's going to be E is equal to HV divided by wavelength. And that's going to be equal to negative Rydberg constant times, in parentheses, 1 over Ni squared minus 1 over Nf squared, close parentheses. Rydberg's constant is going to be 2.18 times 10 to the negative 18th joules per electron, and Planck's constant is 6.6 times 10 to the negative 34th joule seconds. All right, cool. What does magnetic quantum number tell you? It tells you the orbital in the subshell. What is an orbital? It's like a region that an electron is likely to take up space in. I'm gonna give myself a good on that. That was rewording that answer. Which is the first quantum number? It's crazy that this is now that's gonna show it. Which is the first quantum number? The first quantum number is gonna be that's like the energy level, but the principal quantum number. What is happening when an electron is promoted to? When it's promoted, it absorbs light energy. Or it absorbs energy. Yes. I'm gonna say again, but the azimuthal quantum number represents the subshell. What is the off-bow principle? I think this is like you fill up the orbitals from the lowest energy level to the highest energy level, like off bow, A, B, C, like fill it up in order. Yeah. What is happening when an atom is demoted? It releases energy in the form of light. What is an absorption spectrum? this means. This kind of confuses me. Going from shell 1 to shell 2, an electron jumps from a lower energy shell up to a higher one. This requires absorbing a photon because moving an electron farther from the nucleus takes energy input. An electron falls back down from that higher level to the lower one. This releases a photon because the electron is moving to a more stable lower energy position, and excess energy has to go somewhere. It's the same. It's basically saying that the energy difference is the same, and the photon absorbed from going from 1 to 2 has the same wavelength as the one going from 2 to 1. So by that logic, do the absorption spectrum and emission spectrum. Okay, I'm gonna show you guys the difference. It's kind of cool actually. I never realized this. So it's like they're like polar opposites. They literally just like it blacks out the ones that are absorbed here, and it like colors in the ones for the emission. Okay. What is happening when an electron is promoted to a higher energy level? It absorbs energy. What is Planck's relation? I'm gonna say H. I'm pretty sure it's E is equal to HV, if I'm being honest with you. I'm pretty sure E is equal to HV is relation. Oh, yeah, same thing. That's right. B is F. They're the same thing. Frequency is always in hertz. So is it? Well, joules per hertz is the same thing as joules seconds as well. So, okay. So I don't know if it's both. I don't know if it's HF as well as C divided by wavelength. I don't know if they're like one and the same, but I guess so. What is an absorption spectra? Catalog of the absorbed light when going from a lower energy level to a higher one. What are the possible values of the magnetic quantum number, which is ML? It's going to be negative L to positive L. What is Planck's constant equal to? Yes, this is the exact type of question that I need, bro. Thank you. What is Planck? 6.6 times 10 to the negative 34 joule seconds. What is the purpose of the 4 quantum numbers? To identify protons. what is Planck's relation? Um, so Planck's relation is going to be it's going to be E is equal to hs, or c divided by wavelength. Well, it's not or c divided by wavelength. I think s is equal to c divided by wavelength, which I don't think was clearly indicated here. Yeah. What is the purpose of the four quantum numbers? To identify the position, or I guess the approximate position of an electron. Not identify, that's the wrong word. What is Planck's relation? E is equal to hf, or E is equal to hf where f is equal to c divided by wavelengths. What is the purpose to describe the position of an electron? What does the magnetic quantum number tell you? That's going to be ML. That's going to be the orbital in the subshell. How does one calculate the energy required to promote? So it's going to be E is equal to hc divided by wavelength, or negative Rydberg's constant, which is Rydberg's constant is positive 2.18, positive 2.18 positive 2.18 positive 2.18 times 10 to the negative 18th joules per electron. What is the first quantum number? That's the principal quantum number. What is an orbital? It is a region of space where an electron is likely to be found. What is the Aufbau principle? It says that you have to fill up orbitals from lowest to highest energy level. What is happening when it's promoted to a higher energy level? It gains energy or absorbs energy. Absorption spectra is a catalog of photons that are absorbed by a ground state atom in order to get to a higher energy level. What is Planck's relation? It's E is equal to hf, where f is equal to c divided by wavelength. What is the purpose of for it? To describe the position of an electron. All right. Okay. Low key, that was a really short day. I feel like we might be good there. I wanted to do more today, but I honestly think we're just gonna end it off. We might just end it off there. And then I already did extra yesterday, and like, am I making excuses? A little. Um, but I think it'll be fine. I'm not gonna do I'm not gonna do 50 cards forever. And realistically, I like the plan for one chapter a day more than I like a plan for like a hard amount per day. I think if I can do a chapter, it's better. Um, but hold on, I'm gonna set it to like a million. Hold up. Literally just so I can see. I just want to be able to see what the okay. I just put a bunch of cards. Okay, so this deck has 28, 68. None of these have any have a like an excessive amount of cards. Like, okay, these 2 days, hopefully, okay, I'm not gonna lie, oxidation reduction, I'm gonna hate that. So I might combine this with like psych or something. I'm probably gonna end up doing like psych with that. These don't have a crazy amount of cards either, which I guess is good because Orgo's pretty tough. Physics, okay, physics starts getting into light and optics. I'm okay with light and optics, so that's not bad. Um, that's like the biggest one. It doesn't surprise me that, yeah, bio is the one that goes like the craziest. Um, Homeostasis is separated. Why does homeostasis say 78 cards and then it just has digestive enzymes and then you can with two? I guess we'll find that out whenever we do it. Okay. I didn't set it actually to a million. I was exaggerating, but let's set that back to normal. But yeah, I think that's gonna be it for today. Thank you again to everyone watching, and have a great rest of your night.